Okay, welcome to Swell Academy. Today we're talking about solving equations using LCD. LCD stands for lowest common denominator. Usually little warm-up review that comes into play when you're looking at two separate fractions, maybe a 1/4 and a 1/2 and maybe a 1/3. And what you would do with these three fractions is locate an LCD by using its multiples, 4, 2, 3, and kind of climbing the ladder here, 3, 6, 12. Now, once I find the 12 here, I recognize, well, I know 2 goes into 12 and 3 goes into 12. So just to show you, 2, 4, 6, 8, 10, 12, and 3, 6, 9, 12. This is our lowest common denominator for these three numbers. And basically what I could do is convert all three of these fractions using 12, 4 going to 12 3 times, so this becoming a 3, 2 going to 12 6 times, this becoming a 6, and then 3 going 4, this is just a way where I can kind of change the way my numbers are looking. So let's look at an example here where I have x, and I'm solving for a variable, and I have some fractions, and instead of manipulating and trying to add these variables with their fractions, what I could do is greatly simplify this equation by using an LCD. And what I like to do a lot of times too is I like to add that 1 underneath the 3 here, kind of making everything a fraction, and then I can look at the three numbers, 3, 6, 9, 12, 4, 8, 12, and we know 1 goes into every number, so we know 1 will go into 12. And here I have 3 going to 12 4 times, I have 4 going into 12 3 times, and obviously 1 going into 12 times. So that's something to keep in mind as I try to simplify this. So let's look at that. Let me take this equation, putting the 12 outside my lowest common denominator right here, right, using my LCD, and let me simplify this equation by distributing this 12 throughout. Now, 3 goes into 12 4 times. So I'm going to use a 4, and I'm going to distribute that to the x, and I'm going to get 4x. Now I'm going to try to use different colors here so that you guys can see kind of each different kind of canceling out, reducing. 4 goes into, that's too much of a similar color there. Let's use a blue. So 4 goes into 4 once, 4 goes into 12 3 times. So I'm going to use that 3 and multiply it to the x. And obviously 1 goes into 12 times. So I'll use that 12 and distribute it to the 3 here. So basically I've canceled out each of these bottom numbers with this 12 here, and then whatever my result was, I distributed it to that top number, and I get 36. Here's a CLT, combine like terms. 4x minus 3x, x is equal to 36. And if I were to put that in and solve and check, sometimes I like to check my work, see if I'm on the right track there, and do a 36 divided by 3 minus a 36 divided by 4, would that equal 3? And 3 goes into 36 12 times, 4 goes into 36 9, 12 minus 9 is in fact 3. So good way to check your work there. Now let's look at another example where I have some distributing that's taken place in a parentheses and a whole number where I have a 4. This is I really like this question. 4 over x over 2 is equal to 2x plus 1. This is a good thing to look at because this parentheses here is going to change a little bit of our approach. Now, always I want to just take this number and I want to put it over 1, so I keep everything a fraction. I want to look at my LCD between 1, 2, and 5. I recognize 2 and 5 both go into 10. 2, 4, 6, 8, 10. And obviously 1 also goes into 10. So this is going to be my lowest common denominator I'm using. And I'm going to rewrite this question with this lowest common denominator. Oh, blue on blue is not a good choice. We'll use some pink here. Parentheses, 4 over 1. Now what you have to consider is, well, let me just talk about that when I get to it. So 1, we know 1 goes into 10 times. So really there's no canceling out there, but I just want to show it to you because you know it's happening. And I end up with that 40s, 10 times 4, 40. And then I'm going to cancel out my 2 and my 10. 2 goes into 10 5 times. So I end up with a 5 here, and I'm going to multiply that 5 to the x, minus 5x. And then 5 goes into 10 twice. So I'm going to use this 2. Now, keep in mind, you're not multiplying the 2 to what's ever in the parentheses. You're going to direct this 2 to the number on the outside, this 2 on the parentheses. Okay, you're going to distribute this 2 to the 2 and actually make it a 4 and leave what's inside the parentheses to an x plus 1. And this becomes your typical multi-step algebra problem where you want to look at parentheses and distributing first. And then the Miltos motto, right? Move letters to one side, move numbers to the other. Goofy, but that's just what I use. And what I'll do is move x to keep x positive. So I'll move it to the right because I know by adding 5x to both sides, I'm going to create a 9x here. And if I move my numbers to the right, actually made a mistake here. This 4 times 1 shouldn't be a 1, it should be a 4. So I'm going to move my numbers to the left. If I went right with my letters, I'm going to go left with my numbers, subtract 4 to each side. And if you see when I did this, I did my moving of numbers and variables all in one row, but I kept things in like terms. The x's over the x's, the numbers over the numbers. 40 minus 4, 36. Divide both sides by 9, x is equal to 4. And if I were to plug that in to this equation will work out accordingly. Another little thing, last 2 questions we've had, the answers end up in a whole number, which is a nice number to work with. One thing I just want to focus on here is what happens if you end up with a question. Okay, and I just want to show you, I get basically another example as well here. X plus 6 plus x plus 7. And this is a good example of where is equal to 5. Again, make this a fraction. Find your LCD. Find your LCD. And in order to do that, you'll use multiples of 6, 7, and 1. Now, I could go, I have 12, 18, but through experience, I know that the lowest common denominator between 7 and 6 is 42. Sometimes, and we all know sometimes your LCD is just the 2 numbers multiplied together. You can always find a common denominator by multiplying 2 of your denominators together. Whether it be the lowest or not depends on your multiples. But in this case, multiplying these 2 numbers will in fact help me find my lowest common denominator. And here I have a big number. I'm using a big number as my parentheses number here. Let's fill this in and we'll do a little rewrite. And we'll go x plus 6 plus x plus 7 is equal to my 5 over 1. And I just like kind of showing you guys this big number here. I'll make these parentheses same color. We'll do pink and purple, right? And I'm going to cancel out 6. We know 6 goes into 42 7 times. So the 7 is going to go to the x. That's going to multiply. That's going to distribute to the x. And then 7 goes into the 42 6 times. So that's going to go into the x here, multiply into the x plus 6x. And then I have the 1 going into 42 times, which is going to go into the 5. And what I like to do with big numbers, 42 times 5, I like to show this on the side. I like to do 40 times 5 and 2 times 5. I like to break up this number. And we know 5 times 4 is 20, and add the 0. We know 2 times 5 is 10, and that gives me a 210. I don't necessarily write this down all the time, but it is a good trick for mental math. And we have the 13x is equal to 210. If you use any long division or calculator, you would recognize 13 doesn't go into 210, so you can use this as an acceptable answer. It doesn't reduce. So don't be weary or confused if, oh, I have a fraction as an answer. Is that okay? Yeah, it's okay. This could be your final answer. And remember, when you're going through these problems, establish the lowest common denominator, put that denominator outside your parentheses, canceling out each part of the equation one by one, and using that 6 into 42 7 times only to multiply to the part that had the 6 on it. And then when you get to the 7, you'll establish a 6, and that 6 only gets multiplied to the x. Remember, if you want success, just add a little failure. The more you fail, the more you learn. Even if you get a problem wrong, there'll be much that you learn from your mistakes going into the next problem. So some of these may take a few attempts. Thanks for stopping by. Make sure you guys keep working hard.